All right, hello everyone, and welcome. I'm really excited to share with you what's new with explained data. I'd just like a quick show of hands before we get started. Who's upgraded to 2019.3 or later? Wow, that's awesome. Usually there's fewer people, so I'm really glad to have some of you guys who actually have this and can start applying the techniques that you're going to learn today. So my journey with explained data started in June of 2018 with a press release when I was on vacation. And it said, Tableau to acquire empirical systems from the Bayes Probabilistic Computing Lab of MIT. So I Googled these people who were about to become my colleagues and realized, oh my gosh, we're about to acquire some of the best statisticians in the world. I must meet these people. And so in a decided act of ask for forgiveness later, I just didn't go back to London where I live and took the short 10-hour journey to Vancouver where they were meeting 2 days later to be initiated into Tableau. So I showed up to say, hello, I'm here to tell you about our customers. And so now here we are about a year and a half later, and we have this amazing integration between the two technologies where now the minds of some of the world's best statisticians are embedded inside of a tooltip in Tableau. So just to give you guys a bit of context for what you're going to learn in this session and how this is going to go, we're going to play a bit of a kind of tennis match between explained data in practice and then some more kind of principles of statistical interpretation of data. So I'm going to start off by giving you an example of how explained data helps you be a better analyst. And the data set that we're going to be using throughout this session is the Consumer Expenditure Survey. So it's a very important federal survey. It's used for things like calculating the consumer price index. So it's a really rich source of information that has over thousands of columns, and lots of insights waiting to be found. Then I'm going to show you two different courses of action that you could take based on the explanation that you're given in explained data. So you really see how it's about helping guide your next action as opposed to being about giving you the answer. Then we're going to look at interpreting correlations. So a lot of the ways in which explained data presents the information is through correlations, and so it's important to be able to understand some principles of how to interpret that and what is it telling you. So that one's a little bit more kind of theory. Then we're going to go back into explained data and look at a specific example of how filters and calculations and aggregations impact the explanations that you get. Then we're going to look at, at what point should you stop explaining when you just get stuck in a cycle, and at what point should you actually just go and fact-check with another data source if the numbers you're seeing are even right. And that one's a bit more of theory, and then another one that's a little bit more theoretical, looking at confounding factors. And all of this is going to be done on the Consumer Expenditure Survey. And then we're going to go back to explained data and look at how some of the analysis that we've done throughout the session impacts the explanations that you see. As you're adding to your data source, as you're learning things, you actually end up getting better explanations out of your data. And then we'll wrap up with my favorite statistical paradox that I was very delighted to discover in this data while preparing this session. All right, so let's dive in. So first point I want you to take away from the session is that explained data is not about giving you the answer. It's really about helping you be a better analyst. So let's take a look at an example here. So I've mapped out here the average spend on medical services. Now the reason there's not all states here is because the survey samples just a subset of states. So medical services it excludes health insurance and prescriptions, all other things like dentist appointments, private hospital beds, and so on. And so what you'll see here is that Utah has a very high average medical services expenditure, and I wonder why that is. So I'm going to go and select this mark here, And you'll see that there's this new icon, this new option in the tooltip here, this light bulb icon, which I'm going to go and select to explain this specific data point. And so now, explain data is cycling through all of the columns in this data source to find columns that are informative. And it's going to rank and present the most informative ones at the top. If you're on 2019.3, it'll just look through the dimensions. In 2019.4, it's going to consider both measures and dimensions. So we are adding to this with every release. So let's take a look at this first explanation here. Medical trip expenditures by quarter. So it's found this really strong correlation between medical services and trip expenditures. So that doesn't tell you that trip expenditures causes states to have high medical services. Rather, it's telling you that cultures where people value health also value trips, perhaps to the outdoors, for example, is one way to interpret that. It's correlated with healthcare. Quite obviously, it's a subset of the total cost. You'll see that there's this explanation here for number of bedrooms in the household. And so as I select it, I can see that relationship, the number of income earners, the number of babies in the family, the number of children under 18, and so number of rooms in the living quarters. So let me just click on this one here. I'll zoom out and just take a look at this. So far you've seen a few explanations where it's presenting the result as a scatter plot. So if it's using a measure as the explanation, it will show you a visualization of a scatter plot. If it's using a dimension as the explanation, then you get something like this, where you can see that this blue bar is showing that in Utah, a higher proportion of people live in houses with more than 7 to 10, or more than 7 rooms in the living quarters. And this down here is showing you that the average medical services expenditures for people who live in households with more than 7 rooms is higher. And so that's how you can interpret this type of explanation. So what should we be doing with this information? Well, when you look at all of these explanations, they're really pointing at one thing, which is like number of people in the household. And so medical services is quite obviously going to be related to the number of people in the household. So what I should really be doing with this explanation is thinking, like, am I even analyzing the right measure? Like, does it even make sense to look at average medical services? And it may be that, no, that's not the right way to look at that measure. We should rather normalize it by the size of the family. And so I'm going to just go and do that. Just double click in here and then edit this to divide it by the family size. And so now, when you look at the average medical services per person, Utah isn't such an outlier. And so I've used explained data to actually improve the measures that I'm looking at. All right. Let's take a look at the second example here. So I'm just calling this sort of passive versus active analysis. Passive being where you're like, tell me things, like just inform me, computer. Active being more like, trying to think really critically about the explanations that it's generating to guide your analysis to ask better questions. And you'll see that we'll arrive at possibly different explanations through these two different approaches. So in this case, we're looking at the percent of the population that is divorced. And you can see that, once again, Utah is an outlier here, where there is a very, very low percent of divorced people. So I'm going to go and select this data point and hit Explain Data. So once again, it's going to go through all of the columns and find the ones that could be correlated with this. So here it's come up with this measure called HHCUQ, which is well and truly how it's labeled in the Consumer Expenditure Survey. And so maybe I'm feeling lazy and I don't want to go learn what that is. I don't want to have to go look in their data catalog. And so what I'll do is just note that this is another measure in which Utah is a pretty extreme outlier. And so I'm going to just go to that sheet because these explanations are interactive visualizations. So I've just selected go to that sheet, and I now have that explanation here available as a worksheet. And so I can use it to change the visualization, to do further analysis. But in this case, I'm taking the lazy approach of computer, tell me interesting things. And so what I'm going to do is just take this data point here and then re-explain it. So now, when I go select explain data, there's two different measures in this explanation. And so you can explain either one. You'll see up here, it's explaining the HHCUQ. We don't know what it means, but we're going to explain it. Okay, and so it's found this explanation here that a larger proportion of people in Utah are between the ages of 20 and 25, and that people between that age have a higher average HHCUQ. Okay, I don't know what to do with that. I found this other one here, which is showing it's related to cash contributions, which is like tax-deductible donations. And I can see here, again, that Utah is an extreme outlier in cash contributions as well. And so I still don't understand why the divorce rate is high, but I'm still finding these extreme, like how Utah is just an extreme outlier in a lot of ways. And so I'm going to just take the lazy approach again and say, like, oh, why don't I just go re-explain what, like, cash contributions. So let me select this data point and hit explain data again. And so now it's found trip expenditures, but also church contributions. That's interesting. So once again, Utah is a very large outlier in church contributions. And so at this point, you may start, at some point, you may start to draw upon your domain expertise to try and kind of close the loop on explaining that original question of why is divorce low? Now, in my case, I'm not an American. I'm from London. I don't have that much domain expertise about America. But I do know one thing. I once queued for an hour. In Britain, we queue. I once queued for an hour outside the Prince of Wales Theatre to see the Book of Mormon about two missionaries from Salt Lake City on their way to Uganda. And so at this point, I might go, there are Mormons in Utah, and they are making church contributions. Mormons are probably less likely to get divorced than the rest of the American population. And that is probably why divorce is low in Utah. So I've sort of used explain data to get to a point where I can see something, where I can draw a connection with some domain knowledge to finally explain why that first data point was an outlier. Now at this point, who's wondering, why didn't it just come up with that? Raise your hand if you're wondering that. Like, why did we have to go through it 3 times? All right, so let me show you what happens if we were to relate church contributions to divorce, which was the original measure that we were trying to explain. So let me go replace cash contributions with divorce. And you see this interesting thing here, where Utah is not following the normal trajectory. So if we go and add a trend line here and actually exclude Utah, there's actually a positive correlation between divorce and church contributions, except in Utah. And so it didn't present this explanation, it didn't calculate this as an explanation because it cannot be said in general that high church contributions is related to low divorce. And so one of the ways in which explain data is calculating what explanations it gives you is it tries to find things that are true in general and also true for that specific mark. In this case, we just found Utah is an outlier in many different ways. Okay, let's take the same viz and approach this in a different way. So now I'm going to show you how you might get to an explanation if you're applying a little bit more critical thought to the explanations. So let's go and re-explain this. And it's going to come up with what you've already seen, HHCUQ. So let's suppose I didn't ignore what that is, and I actually went and searched in their catalog. What does this measure mean? I would find that it stands for number of households per consumer unit. So a household is people that share the same front door. A consumer unit is people that are financially dependent on each other. So like a family, a married couple, possibly partners living together who share finances. And so multiple consumer units per household could mean a couple of things. It could be that you have all the extended family living in one house, your grandparents, your aunts and uncles, or it could be that you have a lot of flatmates. In England, we have flatmates, living together as well. So I'd like to see a show of hands. Who thinks that Utah is an outlier in household consumer units because big families and extended families are living together? Raise your hand. Okay, and then raise your hand if you, well, it's presumably everyone else, but I just want to see how many hands that is. Raise your hand if you think it's lots of flatmates. Oh, yes, I can't wait to show you guys. Okay, so with this hypothesis in mind now, I can actually validate that question. So something like marital status will give you a pretty good indication about the kind of family situation. So let me just drop this down into more of a box plot type chart. And I'm going to drag in marital status. And so, okay, this is telling you something uninteresting. 100% of divorced or separated people are divorced or separated, so let me kick that guy out. And so now what this is telling you here is that in Utah, the cohort for which the number of consumer units per household is high is people who are not married. So no, it's very unlikely that the extended family situation is happening among unmarried people. It's much more likely that the never married people are like college students sharing an apartment with a bunch of flatmates. And so at this point, let me go and also see what proportion of the Utah population has that marital status. So if I grab the number of records and then drop that on size, and let me just go and do a percent of total quick table calc so that it's not being thrown off by California. And let's compute that along the marital status. And so here you can see that a quarter of the population of Utah is unmarried and living with more, on average, 3 consumer units per household, which is rather interesting. And so if we were to look at this visualization, perhaps in this way here, and like this, now we can see other interesting things about this, namely that if we look at the District of Columbia, a very, very high proportion of the District of Columbia is never married, whereas in all other states it's a much lower population, while DC has very few married people, and the rest of the states have much more married people. So I've also, in this process of exploring this data and trying to explain what's happening in Utah, I've also now discovered that DC is like a pretty extreme outlier in terms of this distribution. Now, another thing I might do with this is create a calculation to capture like interesting distinctions, interesting divisions and groupings in the data. So what we learned from this marital status kind of flat sharing thing is that unmarried and flat sharing is possibly an interesting cohort that is distinct from unmarried and living alone. You're sort of separating out the students from the widows or so on. And so I might want to actually encode that in a calculation that enriches my data model that may come up later on in explanations, for example. And so I'm going to go and add that in here with, no, it was this. And did I go and rename my field? It is called, is it not called that? Oh, sorry, yeah. Okay, yeah, let's just do that again. It's called short keys, #1 asked question after every session. Okay, so I'm creating this calculation here that's grouping together the unmarried people who live in households with more than one family into unmarried and flat sharing. I'm also grouping together the unmarried and no flatmates, and then for everyone else, I'm just saying like, whether they have flatmates or not is like probably uninteresting because that's not a very large cohort. So this is now some kind of conditional breakdown of like cohabitation and marital status. And if I were to look at this scatter plot, again, breaking down the data by my new calculation, there we go. So let me just color by this instead. Now it's gone and like really separated out that cohabitating, that unmarried flat sharing cohort. They're like all special, well, across all of the states. But the reason you weren't seeing that before is because the proportion is so small in other states that the average gets diluted when they're grouped together with all unmarried people, because most unmarried people live in households with fewer consumer units. So just an interesting kind of show of what's actually happening when you're segregating data in different ways and how that changes your aggregations pretty radically. Okay, so let's now, yes, we were explaining why divorce, let me come back here. We were explaining why divorce is low in Utah. So, and we discovered some interesting things about marital status. And so what I'm going to go do is exclude the unmarried, or like the never married people, as a result of having learned that they are a distinct group of people. And I meant to hit exclude rather than keep only. Okay, so now we're looking at the percentage of the population who has been married at some point in their life, but is now divorced. So let's go and explain Utah on this population. And now we are getting a very different explanation than when we had included unmarried people in the data set. What we're seeing here is that family size is highly correlated with low divorce across all states. That's a very strong correlation. If I go and remove this here, you can see that it is indeed a very statistically significant correlation. So this is, if we go and now make a comparison between the two approaches, the one where I got to like, oh, they donate to church versus they have large families, we really got two different types of explanations. The first was a weak explanation, which is like, Utah's an outlier on both of these things. Whereas the second explanation here is saying that, in general, states where people have large families have low divorce, presumably because they value family. And people who value family are less likely to get divorced. So that's a much stronger explanation to say something that is true in general and then describe how that thing that is true in general also applies to your data point of interest. So now looking at this, you may be wondering, or I was wondering anyway when I first saw this, if if family size is correlated with divorce and church contributions is correlated with divorce, does it follow that family size and church contributions are also related? Like, do the states where people donate more to church also have larger families? And so let's just go and look at this sheet here. And let me break this down by, so let's bring in the church contributions. And here it looks like church contributions increase with family size, except if you exclude Utah, that's no longer true. So Utah was really pulling the entire weight of that correlation. If you look across all states except Utah, there is no, this is not, it looks like it's going down. It's not a correlation, it's just random. And so Utah is somehow different in the relationship between family size and church contributions. So let me go and change this viz a bit here. Let's make this a dimension. Let's make it discrete. And then let's group together all of the data points for kind of families of 6 and more people. So let me just go and alias this with 6 or more people. And so if we remove states and just compare Utah to the rest of the states, you see this interesting thing where in Utah, the bigger the family, the more they're donating to church. Whereas in the rest of the states, there's not really a relationship between family size and church contributions. And so if we wanted to make the kind of explanation that, the first explanation, which is like, there are Mormons in Utah and Mormons don't get divorced, a better kind of line of reasoning to applying that would be to say that people who are Mormon value like large families, and as family size is increasing, as you can see here, as family size is increasing, the percentage of like the divorce rate is decreasing. So these kinds of, this line of reasoning comes up in business all the time, with business data all the time as well. All right, so let me go through and just describe this kind of general problem we've seen with like correlations and how they can reverse at different levels of detail. We've seen this like very bizarre correlation between divorce and religious contributions. Like how is it possible that such a crazy positive correlation exists? And does this mean, and just because religion and divorce are correlated on a state level, does it mean that the people who are getting divorced are also the people who are making church contributions? So it's really important to keep that distinction between like individual people versus the states that they live in. And so we can go and answer that question fairly easily in Tableau. And so here we're looking at the conditional probabilities versus the baseline. So your baseline of divorced people is 13%. But then of the group of people who make church contributions, only 10% are divorced. And so that tells you that people who make church contributions are less likely to be divorced, which is much more in line with what you would expect. And then conversely, when you look at the kind of baseline percent of population who makes church contributions, it's 9% of people. And then of the people who are divorced, only 7% are making church contributions. And so likewise, people who are divorced are less likely to make church contributions. So this probably fits your mental model, your expectation of the relationship. It does hold at an individual person level. And so how do we then like rationalize this with the fact that we're seeing this like strong positive correlation at the state level of detail? And so this is where you need to apply some kind of thought to what is happening in the underlying distribution of this average value here. So if you think, for example, let's say you have a measure, you have 100 rows, and the measure column is null for 99 of those rows. The average will just be equal to the measure value for the one row. But that average is probably not that interesting because the majority of the records is null. And so this is where we need to start thinking like, you know, what's the overlap between the proportion of people who are divorced and making church contributions, and what's the total percentage of people making church contributions, and is it possible that of that small cohort, the average is just being dragged up by like a couple of outliers. So here this bar chart is showing the intersection between people who are divorced and people who make church contributions. So you can see here that there's this like 9%, only 9% of people are making church contributions. So important to keep in mind that average value is null for 91% of the records, which makes it like questionable. And then of the people that are both divorced and making church contributions, this is only 1% of the people surveyed. So one approach to when you see something like this is like, can I make the correlation just disappear? And one way to make the correlation disappear would be to replace the null values with zeros. Because if it's true that the average is just being dragged up by a couple of people who make massive donations, when you enter like zeros for 91% of records, that'll really like dilute those kind of extreme values. So let's go to this sheet here. Oh yes, another thing I wanted to mention is like when you're trying to explain why this relationship exists, a common tendency is for people to look at like the largest value and then try and explain the relationship based on something they happen to know about the largest value. So just to give you an example of a poor hypothesis here, a poor hypothesis would be, Las Vegas is in Nevada. Las Vegas has a lot of chapels, and so therefore there's a lot of religious people in Las Vegas. But people who are getting divorced, or people who are getting married in Las Vegas, are more likely to get divorced. And so therefore, high divorce is correlated with church contributions. Now, it sounds ridiculous when I'm saying it in this context, but this is sort of the line of reasoning that often gets applied to these types of correlations. So this is a pretty poor hypothesis for a couple of reasons. One is that you can't actually validate it. And two is that it may explain why Nevada has high divorce and high church contributions, but it doesn't tell you anything about the other states. All right, so let's go and try and make this correlation disappear. So I'm going to go and replace all of the null church contributions with zero, with the Zn function. And alas, it survives. It is not going away, this correlation. But what it has done is it's popped out Alabama, which previously wasn't really much of an outlier here. And so if you think about, like, wait, why has this happened? Because it could have something to do with the fact that more people in Alabama were making church contributions. So if you had, like, let's say, 80% of people were making church contributions, when you enter zero for the other 20%, that's not going to dilute the average as much as otherwise, if there was only 1% of people making church contributions. And so, in fact, we can go and validate that. If I select Alabama here, you see that that's exactly what is happening, where more than twice as many people are making church contributions in Alabama. And so that's why it has sort of survived despite the kind of replacement of nulls with zeros. So with this example, I'm really just trying to get you guys to think about the underlying distributions and how that influences the numbers that you're seeing and how that influences correlations and so on. So we've gone and looked at trying to like squash the correlation. That failed. We may then, at this point, you may want to try to explain it in terms of another confounding factor. And what's common is that the confounding factor doesn't actually exist in your data set. So when you see weird things like this, always be thinking about like things beyond the fields that you see in the schema viewer of Tableau. And in this case, if you were to go and Google why is divorce so high in religious states, some explanations is that people who go to church have the lowest divorce rate, whereas people who are identify as religious but don't go to church have the highest divorce rate, and atheists are somewhere in the middle. The reason being that they sort of pick and choose which values of the religion that they adhere to. So, for example, people who are religious but don't go to church may be more likely to get married in the event of an unplanned pregnancy, which would make you then consequently more likely to get divorced. And that's possibly why you see this correlation in the data set here. So always be thinking about things outside of your data. All right, so we took a small detour into the realm of kind of statistical explanations, statistical interpretations. And I'm going to bring it back now to explain data and looking at how things like filtering and aggregations and calculations impact the explanations that you see in explained data. So at this point, so we've seen religion and divorce is correlated. We first explained divorce. Now I'm going to come and explain church contributions here. So let's start out by explaining Nevada. Whoops. Given that we are in Nevada. So it's come up and said that there's no explanation found in the data. And so one thing I could do is exclude Utah, because Utah is primarily a different religion to the rest of the states, and we've seen that Utah is quite an outlier and can really change the correlations that happen in the underlying data. And so if I exclude that, now let me go and explain Nevada. And so now it's come up with an explanation. In this case, it's come up with the explanation of year. And if I scroll down, I'll see here that there are only church contributions up until 2001. And the last 18 years of the survey didn't have that field on the survey. And so let me go to this sheet here. And I'm going to just save these years here in a set. And then I'm going to go back and actually filter down to just look at that set of years. And so adding that filter doesn't change the number, because the average is the same with or without the null values. But what it does do is remove 18 years of underlying records that are being considered in the explanation. So now the explanation is only going to operate against that 6 years of data. So now that I've excluded those years, let's go and re-explain Nevada here. And now you will see that it's coming up with the explanation that church contributions are positively correlated with divorce and separation, as we would expect. So it didn't come up with it immediately, but when you exclude the data point that's throwing this correlation way off, and when you restrict the record set down to just the relevant years where people are making church contributions, it does find that correlation. All right. Let's look at another evolution of this visualization here. So in survey data, when you survey an individual, that person represents about 15,000 other Americans. And the survey includes weights to recalibrate how many people are represented by one survey participant. So if you have way more people over the age of 60 responding to the survey, those people will be representing less of the population. So what I've done here is take the average church contributions and then use the survey weights to recalibrate them. So what that looks like here is I'm just multiplying and dividing by the weights. And I'm using the Zn function here again, so we're representing the people with no contributions as 0. So this is an aggregate kind of ratio calculation. If you're using 2019.3, we actually can't explain this yet in 19.3. But I'm using 19.4, and in 19.4 we can. So let me go ahead and now explain Alabama. Why does Alabama have such high weighted church contributions? And it's come up with no explanation. So with ratio calculations, in the current version of Tableau, this probably won't be true for long, but in the current version of Tableau, it only looks at dimensions as potential explanations for ratios. And so I can, if I take measures and create bins out of them, they may then appear as explanations. So one thing that I'm going to go do here is create a bin calculation that splits up the church contributions. And again, I showed you the answer, and now I'm going back just to illustrate the mechanics of explained data here. But we saw that there's some interesting things with the proportion of people in Alabama who are making church contributions, and also like whether it's lots of people making medium-sized donations or one person making large donations. And so if I split the church contribution value up into bins here, that was supposed to, is it this one? There we go. All right, so I'm basically taking church contributions, which is a measure, and converting it into a dimension through these bins here that are going to group together different values of church contributions. So let me go and now save that calculation. And then let's re-explain Alabama. All right, oops. There we go. And let's explain this particular value. And now it has come up as an explanation. And you can see here that a smaller proportion of the population is making no contributions. And it's giving this description here that marks with this distribution have higher aggregated values for the weighted church contributions. So in some cases, if you're explaining a ratio, creating dimensions could help get explanations out of your data. Now, let's go and look at, we know that divorce is correlated. And so what if we created a calculation that identifies if people are divorced or separated? So I already have this as a set here. Now another just kind of implementation note on explained data, it doesn't yet use sets or groups or bins as explanatory fields. That won't be true forever, it just happens to be true right now. So what you can do if you want your set or group to be referenced or used in an explanation is simply create a calculation that references that. So let's see now what happens if we go and explain data on this, having added this field indicating if people are divorced or not. All right, so let's explain data. What happens? And so we know it's going to come up with this explanation for the bins, but it hasn't actually come up with divorce as an explanation. I wonder why. Well, it could be that divorce isn't in aggregate interesting as an explanatory field, but when considered in combination with something else, it may be interesting. And so if we were to look at, say, the divorced population who is also making church contributions, maybe that population is different and interesting. And so if we created, instead of a calc just looking at that one field, but rather a calc that combines both the church contributions and divorce, perhaps that will give you an interesting explanation. And so here I've just gone and added that calculation that was in that stacked bar chart we saw, breaking down whether people were divorced and making church contributions, et cetera. So let's call this marital status and church contributions. All right, so with this, let's now take that particular data point and go and explain it. And if you're wondering why is this dialog box taking a while, it is because there's, I think, over 1,000 fields in the underlying data source. A side note I will add is that if there are fields that you know are definitely not interesting in generating explanations, you may just want to hide them because it will make explained data run faster. All right, so now, while divorce on its own didn't show up as an explanation, the combination of divorce and church contributions is showing up as an explanation. And it's because there's a larger proportion of people in Alabama who are divorced with no church contributions, and a much smaller proportion of people who are not divorced and not making church contributions. All right. Let's now look at a third example here of using filtering and so on to explain data. So we're looking here now, I've added Utah back in. We're looking at the weighted contribution to religious organizations. In this viz, I'm representing the nulls with 0. So let's say I wanted to explain it just for the population that has made religious contributions. I could take that measure of church contributions and then go and filter out the non-null, just go and filter out the null values. And so now if I explain the weighted contribution just for the population who makes contributions in Utah, let's see what we get here. So, wow, we're getting this crazy, crazy distribution for age, where over 40% of the survey respondents in Utah are between the ages of 18 and 24. It's a 6-year age bracket that contains 40% of the respondents. We're also seeing that marital status is an explanation here. And we can see again that there's over 40% of people who are never married, and a lower proportion of married people in Utah. Now, if you remember back a few steps, when I was creating this scatter plot, we made a calc combining flat sharing versus not flat sharing for unmarried people. And that calculation is now showing up as an explanation here as well. So while it identified married people, it's that there's a radically inflated proportion of unmarried flat sharing people in Utah, and actually fewer unmarried people who are living alone, which is rather interesting. And so if we go to this visualization here and look at why would church contributions be so high when you have 40% of your population between the age of 18 and 24 flat sharing and being unmarried? That does not seem like the cohort of people who would be donating money to the church. And so we can look at this further if I break down the average church contributions here, and let's look at this in Utah versus not Utah. And so what you see here, actually let's do this as a bar chart. We'll show it a little bit better. And if we do that, and unstack the marks. And so what you see here is that, there we go, matching the explained data one. Okay, so what you see here is that people who are married are making radically larger contributions in Utah versus in other states, whereas the unmarried flat sharing cohort is actually making a lot less contributions than in Utah. And the reason for that, if we bring in the age, which we saw is 40% of the population, we can see here that there's this massive proportion of the population who is never married, flat sharing, and between the ages of 18 and 24. It's, in fact, almost a third of the population is of that specific demographic in Utah. And so at this point, we could continue to hit explain data and get explanations like people are unmarried because they're young, people are young because they're unmarried, and just go in circles over and over again. But at some point, you reach a point where you should just stop explaining and start fact-checking the data. Is this possible that that's such a large proportion of the population. And so I've compared this here to census data, which is the gold standard for sort of population data. So let me just simplify this. We'll just look at so this is looking at the weighted population. So this is after the Bureau of Labor Statistics has adjusted their survey for sampling bias. And it's saying that over 40% of the population in Utah is between the ages of 18 and 24. Whereas when you compare this to census data, it's much, much lower. And so the young people were dramatically overrepresented in this survey up until about 2010. And in more recent years, young people have become underrepresented. If you think of the impact of that, it's rather massive. These people, their responses are being used to determine the consumer price index, which is being used in economic calculations of inflation. If 40% of the people are that young, those are not people with a lot of money, and so they will not be representative of the rest of the population. Now, another thing I thought I wanted to look at, so this is looking at the number of records. In this data source, when a person participates in the survey, they actually take up to 5 different interviews. And so if you were to, instead of looking at the percentage of interviews by age group, look at the percentage of households, you'll see a very interesting thing. So if I look at weighted, weighted number of households between 18 and 24, it's actually even higher, which is bananas. Now it's saying it's over 45% of households are between the age of 18 and 24. And so this big discrepancy between the number of interviews and the number of households tells you something interesting, which is that young people complete fewer surveys. They're more likely to drop out of the 5 along the way. And so that in itself presents an opportunity for a very interesting analysis. And so I'm going to just, so in this case, if you wanted to see now the number of interviews completed by age, we could go and count per consumer unit the number of records. And that's going to tell you the number of interviews that that person completed. Interviews per person. And so then it's interesting to see how that varies by age. Should have pre-made the calc. All right, so if we look now at this average of this measure and then break it down by age, you're going to see this interesting thing, which is that young people complete much fewer surveys, and older people are more reliable in completing the rounds of the interviews, which is rather interesting. And so now, what if you wanted to break that down by gender? You see this really interesting distinction here where women complete more surveys than men. And so at this point, it may be tempting to say women are more reliable than men. It's very, very tempting insight to draw. Well, what if we break this down even further by marital status? In this case, you can see that it's the married couples, if we go and group all of these other ones here, it's for married couples where the discrepancy is really large for women. And so you're like, oh, the wife is reliable. It's like a very tempting explanation to make. And so this is where we need to look at the underlying distributions and what types of confounding factors might be driving this relationship. Also important to look at the number of records in how these are distributed. So if I go look at where are the records, you see here this crazy reversed trend for single versus married people, where the older people are if they're married, the higher proportion of respondents are men. Now, if you go and look at how the Consumer Expenditure Survey is conducted, they ask married couples, the person who is most knowledgeable of the household, please respond. You're like, if ever there was a generational gender bias, it is that one. So imagine in your grandparents' generation, your grandfather is probably more the knowledgeable one. In your parents' generation, it might be your mother, and so forth. And so that's actually what you're seeing here, is that the older population, in the older population of married people, the man is more likely to respond. And so this begs the question, things are changing over time. Could the sort of progression of time with who is the knowledgeable person be changing what we're seeing? So I've just restricted and simplified this down here to look at married people. And watch what happens when we animate this by year. 1996. And over time, they converge and they converge and they converge more and more and more and more. And so if you go back to the original question of, are married women more reliable, and is that why married women are completing more of the surveys, it is not true at all. When we filter this visualization here by year, what happens is, if we look at just a couple of years here, that distinction between women and men completely disappears. And so the reason that we're seeing this distinction when we look across all years is because in the early 90s, actually I should have filtered to the 90s instead. In the early 90s, let me remove that. In the early 90s, people completed much fewer surveys. So if you watch the average number of interviews per person, they are climbing over time. So in the earlier years, when men were more likely to respond, the survey was basically less effective at getting people to respond to repeats. And so that's why you end up seeing this trend where it looks like women are more reliable than men. And so always be thinking, when you see these interesting relationships that feel like they may be able to draw some grand conclusion about the universe, about some unknown insight, it's actually more likely that there's some other factor, some other distribution, perhaps bias, that is driving that. And so as an analyst, a lot of the job is not in trying to identify insights, but rather than trying to understand if the data that you're looking at is actually comparable. And so with that, I'm going to skip the last part. It was another example of, well, I may as well show you this. So if you add in a calculation, all right. So if you add in a calculation, now breaking down the gender, male versus female, within marital status, and then go back and explain Utah, so let's exclude, so we've learned a few things. We've learned that never married flat sharing people are different, so I'm going to exclude them. And I've added in this calculation that splits out gender for married people, because we've learned that that's interesting as well. So if we come here and explain weighted religious contributions for people in Utah, gender comes up. There's a much higher proportion of men. And then when you break the gender out by marital status, you see that there's a much, much, much higher proportion of married men versus married women. And so the interesting insight here is not really about religion and not really about divorce at all. It's really about how different cultures introduce bias in the collection process of the data in this incredibly important survey for economics and policy decisions. Now, we have 1 minute, and with that 1 minute, I'm going to show you a manifestation of my favorite statistical paradox, which is Simpson's paradox. So if we look at the percentage of, or the number of people by marital status who are married versus unmarried. So what percent is that? break this down by marital status. And now if we split this out by Utah versus other states, you can see that in Utah, a smaller proportion of the population is married than in all of the rest of the states. But now, what happens if we break this down by age? So I'm going to grab the age, 10-year age bins, split this out here. Let's make this a line, and let's put this, hold on, what was I trying to, nope. I've forgotten how to do Tableau in the panic of time, so let me just go and show you the final visualization. Oh, don't tell me it's not saved anywhere here. I didn't save it, you're joking. I'm gonna have to just, just one moment, let me reflect, because this is huge. If you Google Simpson's paradox, there's one example from the 70s, and now we will have two. So if we go back and go back, oh my gosh, and go back, and go back. Thank goodness for the back button. All right, so I wanted to compare, this is what I wanted to do. Utah, there we go. Utah versus other states. Here it is. Okay, by age group, every single age group has a higher proportion of the population that is married in Utah. So in aggregate, overall, there's a smaller proportion of married people in Utah. By age group, there's a higher proportion of married people. Who knows why? Why is this happening? A lot of young people, exactly. There's a lot of young people that is skewing the average when you're looking at the data in aggregate. And so for many of you who I've spoken with this week, you're like die-hard data fans, and you have to go back to your company next week with 50,000 people asking you for PDFs. Raise your hand if that is true, if you're in that bucket. All right, so for those people who believe they only need to look at data in summary numbers as KPIs, as in static PDFs, please show them this example of how their data may be lying to them because of the distributions, the hidden distributions. And that is why we need interactive exploration of data. I'm over by 3 minutes, but thank you so much for coming, and happy to speak with any of you and take questions.